right, subtracting functions here. F of x minus g of x squared plus 8x, particularly with subtraction, I want to leave it in parentheses. X squared plus 8x, the minus or the negative gets distributed to both terms, and then we combine like terms. So my answer is going to be C. G of f is very similar to this. Okay? Where I'm going to take the f of x, whatever it is, in this case x cubed minus, or x squared minus 3, and put it in wherever I see x. So it's really something like this. G of x squared minus 3. So I replace the f of x with x squared minus 3. Wherever I see an x in the g function, I put x squared minus 3. So it's 2 times x squared minus 3 minus 1. 2x squared minus 6 minus 1. We have 2x squared minus 7. Third one, 2x minus 3 cubed. 2x minus 3 times 2x minus 3 times 2x minus 3. I'm going to FOIL out the first. 4x squared, negative 6x, and negative 6x is negative 12x. And then negative 3 times negative 3 is 9. And then we distribute through. 8x cubed minus 24x squared plus 36x. Oop. Do I want to do 4x squared? Sorry, let's start that one again. Thanks. Let's do 4x squared times x. Let's do 8x. Let's do 8x cubed. 4x squared minus 3 minus 12x squared. Let's go in that order. Negative 12x times 2x, negative 24x squared. Negative 12x times a negative 3 is plus 36x. 9 times 2x is 18x. 9 times negative 3 is negative 27. And then we got to combine our like terms. 8x cubed minus 36x squared plus 54x minus 27. So that answer is going to be C. Number 4, state the domain and range of the function graphed on the right. This goes to the negative 4, so we're going to bracket negative 4 for the domain. The domain is negative 4 to infinity. The range is 0 to infinity. But we hit those numbers. The graph does go to that 4. There's no open dot there. So that means we're going to bracket the negative 4 and we're going to bracket the 0. Okay. If you notice from a multiple choice standpoint, the bracket is the only difference in choices A, B, C, and D for domain. Since I know I need to bracket it, B and C are my only options. So now I'm determining, am I going from 0 to infinity, or is I'm going from negative infinity to 0? This is obviously going from 0 to infinity, so my answer is B. All right, determining whether something is an inverse, we're simply just making the xy and the yx. And then we resolve for y. X minus 3 equals 5y. X minus 3 over 5 equals y. X minus 3 over 5 equals y. There's my inverse. To determine a pair of functions that are not inverses, I'm going to do a right example and a wrong example. The ones that are not inverses is that. And I'll circle it right away. And the reason why is this. When you plug 1/2 x minus 9 in for x, you end up with not x. You end up with x minus 9. Okay. And the reverse would work as well. Okay. In the sense that it won't work out. So if I plugged 1/2 and then I did 2x plus 9 minus 9, Now I get x plus 4.5 minus 9, x minus 4.5. I don't get x back. That means they're not inverses. Just to show you when something is an inverse, let's do C. 3 times 1/3 x plus 2 minus 6. Well, that's x plus 6 minus 6. That equals x. If I went the other way, and I went 1/3 3x minus 6 plus 2, I would get x minus 2 plus 2, which also gives me an x. Therefore, it would be an inverse. Okay? All right, so this one here, we have the cube root of 256t to the 4th. Okay, for the exponent, it's just 4 divided by 3 is 1 remainder 1. The quotient goes on the outside, the remainder goes on the inside. So I should have t cube root of t. I also need to break down the 256. So 256 is 2 and 128, 2 and 64, 2 and 32. 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Pair of threes. Or 3 threes, I should say. So we have 2 pairs of 3 groups of 2. Okay. Since the index is 3, I need the number to show up 3 times for me to pull it out. The 2 shows up 3 times twice, so we multiply it. 2 times 2 is 4. And then we multiply whatever is left that's not going in the that's not going outside the absolute or the radical. Okay, so you have the 2 2's left over. 2 times 2 is 4, and that is your answer. And the answer is 4t cube root of 4t. It is not a plus minus. Since the index is odd, there is no plus minus with it. Okay, remember. The cube root of 8 is 2. The cube root of negative 8 is negative 2. So you don't have to account for both signs there. 32, I'm going to break down. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Pair of 2's, and a 2 left over. So root 32 simplifies to 4 root 2. Root 18, 2 and 9, 3 and 3. We have a pair of 3's with a 2 left over. So it's minus 3 root 2. Root 54, 2 and 27, 3 and 9, 3 and 3. Pair of 3's with a 2 and a 3 left over. So that's plus 3 root 6. And then 150, 2 and 75, 3 and 25. 5 and 5, pair of 5's left over, so it's 5 root 6. And now we're combining like terms. 4 minus 3 is 1, so it's 1 root 2, or just root 2. 3 root 6 and 5 root 6 is 8 root 6. So my answer, root 2 plus 8 root 6. Number 9 is a gift. We should know at this point exponent over index. So our m can be written as m3 to the 5th. And 3 to the 5th is right here. Number 10, we're using our calculator. Okay? I'm given the original amount, 3,000. The inflation is 6%, so 1 plus 0.06. Now I have to be careful with my decimal here. N represents years. They want to know the price after 6 months. How much of a year is 6 months? 1/2. Okay. 3,000, 1.06 to the 1/2, which is really the square root. All right. And then when we multiply that, we get 3,088.69 cents. You round to the nearest cent. Number 11, which one represents growth? It's all about the number that gets raised to an exponent. When the number being raised to an exponent is greater than 1, that's growth. When the number being raised to the exponent is less than 1, that's decay. So this one, without really doing any work, is A. The number being raised to the exponent is bigger than 1. For number D, we don't know, or with letter D, we don't know what the X is, so we really can't answer it with D. It's got to be A. Okay, here we need similar bases. 2 squared to the 2x plus 7 equals 2 to the 5th to the, I believe it says x plus 1, but it's hard to read. X plus 3. Thank you. All right, so this becomes 2 to the 4x plus 14 equals 2 to the 5x plus 15. Once I get to the same base, we're just setting the exponents equal to each other. 4x plus 14 equals 5x plus 15. The bases don't mean anything anymore. I'm going to subtract 5x, or I'll subtract 4x on both sides. I'll subtract 15 on both sides. And negative 1 equals our x. So my answer is going to be B. For number 13, got to get to a similar base. So I'm going to use 3 as the base for both of them. 3 to the negative 4 is 1 over 81 t. 3 to the 5th, t minus 2. So this becomes 3 to the negative 4t equals 3 to the 5t minus 10. And now I'm going to set those two equal. Negative 4t equals 5t minus 10. I'm going to subtract 5t on both sides. Negative 9t equals a negative 10. Divide negative 9 on both sides, and 10 ninths is my answer. And 10 ninths ends up being the B selection. Number 14 is straightforward. This raised to this equals this. 81 to the 4/5 equals 243. It's a straightforward problem here. Okay? That's how you have to write that. Okay. Number 15, we're just solving, same deal. So we have 1/8 to the negative 1 equals x. When you raise a fraction to the negative 1, you flip the fraction. And your answer ends up being E. So A is your answer here. Number 16 is pretty basic. When you have the log on both sides, we're just setting 7x minus 3 equal to x plus 12. The logs on both sides make this pretty easy. You subtract x, you add 3, and you end up with 6x equals 15, which is 5 over 2. 15 over 6 reduces to 5 over 2. And your answer is 5 over 2. We're going to circle A again. So evaluate log base 512. It's simply log 12 divided by log 5. Make sure you close the parenthesis on the 12. Okay? And you end up with 1.543. Rounded to 1.544. Okay. Here, the addition means you multiply. Log base 3, a squared minus 8a equals 2. And now it's this raised to the 2, goes back to your log. A squared minus 8a equals 3 squared. A squared minus 8a equals 9. A squared minus 8a minus 9 equals 0. A minus 9, A plus 1. Now, this is huge on the multiple choice test. See how I have 9 and negative 1? Can you have a log of a negative 1? No. You cannot take the log of a negative, so it's just 9 as your answer.